The meaning of differentiation is rate of change. Rate of change. Say that is the symbol, normal symbol that we use for differentiation is dy upon dx. There are all the other symbols also, like we can use f dash x, we can use y dash, we can use y1. So these are the various symbols of differential. This is read as d upon dx of y, but that is normally is called dy upon dx. We read it like this, although it is d upon dx of y. So d upon dx of y means rate of change of y with respect to x. Let me make it clear. Look, say for example, that is there is a function in terms of y. So y is equal to fx. If there is any change in the value of x, there will be a corresponding change in the value of y. That is, if it becomes x plus delta x. In place of x, if there is a corresponding change, x plus delta x. Delta x is the same as h. जो हम लिमिट्स में h यूज करते थे, that is delta x only. तो अगर if there is a small change in the value of x, there will be a small change in the value of y. Is it clear? If we subtract the two, delta y will become fx plus delta x minus fx. That's the delta y. Now, if we study this change in terms of y with respect to x, that is differentiation is delta y over delta x. So this will become fx plus delta x minus fx whole upon delta x. This is differentiation. That is rate of change of one variable with respect to another variable. Rate of change of one, that is, this is the change in y with respect to x. So this is पहले आप इतना नोट कर लो. We'll be doing the definition of differentiation and then I'll come back on this. एक बहुत important concept है differentiation में, first principle. So that time I'll come back on this topic. Now look, the whole of the differentiation can divide into basically just three parts, three parts. Now look here, so this is everything that we need to know in differentiation. The first thing is the direct form. These basic results in differentiation, d by dx of x to the power n. That is when we need to differentiate x raised to the power n. It becomes nx raised to the power n minus 1. We will be doing the derivation of all these, all the results. D by dx of a raised to the power x is a raised to the power x log d by dx of e raised to the power x is e raised to the power x. D by dx of log x is equal to 1 upon x. Then trigonometrical functions, d by dx of sin x is equal to cos x. D by dx of cos x is equal to minus sin x. D by dx of tan x is equal to sec square x. D by dx of cosec x is equal to minus cosec x cot x. D by dx of sec x is equal to sec x tan x. And lastly, d by dx of cot x is equal to minus cos x square x. These are the 10 standard formulae that we use in differentiation. So d by dx of x to the power n and so on. I'll come back on this point. अब ये सारे results हमने derive कैसे किए? All these results are derived by using the method which is known as first principle. In fact, this is such a strong method that you can practically differentiate any differentiable function by the help of this method. I repeat, you can differentiate any differentiable function. That is, it is possible, it must be possible, or the differential of that function should exist then only. So we can differentiate any differentiable function by using the method of first principle. There are other names for first principle also. We call it differentiation by using limits. So whatever we have done in limits will be again revised in this. It is also known as ab initio method. Differentiation by using first principle, by using limits, or by using ab initio. जो अभी हमने स्टार्ट किया था स्टार्टिंग में, that is delta y over delta x is equal to fx plus h minus fx. The same thing, that is the differential of any function f dash x. Differential can be represented by f dash x. This is equal to limit h tending to 0 fx plus h minus fx whole upon h. One single formula which can help you to differentiate any function. F dash x is equal to limit h tending to 0 fx plus h minus fx whole upon h. I'll clear this with an example. Look very carefully. If fx is equal to x square, find f dash x by using first fx हमें given है, we need to find out f dash x by using first principle. fx is x square. What will be fx plus h? If fx is x square, what will be fx plus h? X plus h whole square. That is, this is the first thing that we need. That is, replace x by x plus h. So x plus h of whole square. Now the formula for f dash x is limit h tending to 0 fx plus h minus fx whole upon h. Watch carefully. X plus h of whole square minus x square whole upon x. Now try to recall the first formula in limit, or first one be, that is one basic formula in limits that we have done. Limit x tending to a x to the power n minus a to the power n upon x minus a is n minus 1. ऊपर जो टर्म्स विद पावर है नीचे सेम टर्म्स विदाउट पावर होनी चाहिए. यहाँ पर ऊपर टर्म्स है x plus h of whole square minus x square, बट नीचे खाली h है. थोड़ी सी मैनिपुलेशन, एक x ऐड किया, एक x सब्ट्रैक्ट किया, वही फॉर्म आ गया ना. ऊपर जो टर्म्स विद पावर है नीचे सेम टर्म्स विदाउट पावर. नाउ व्हाट्स द फॉर्मूला? n minus 1. So this will become 2x to the power 2 minus 1. So just 2x. So f dash x की वैल्यू यहाँ पर 2x आ रही है. So we can say that d by dx of x square is 2x. So by using one single result, we can differentiate any function. जो भी function हमें given है, that is, ये जो सारी derivations हम लोग करेंगे, we will be using this result only to obtain the differential of all the functions. Am I clear with it? If I talk, please pay attention. From the exam point of view, there will be definitely, in whichever school you are in, whichever section you are in, there will be definitely one question based on first principle of minimum 5 or 6 marks. That's for sure to come. Now, besides this first principle, the third thing that we have are the rules of differentiation. Look. D by dx of a constant function, that is, which is a pure constant. See, what was differentiation? What's the basic meaning of differentiation? Rate of change. Does a constant changes? So what will be its differential? 0. The differential of a constant, pure constant function is always 0. But if the constant is multiplied with a function k into fx, then k will be written outside and we will differentiate only the function. दैट इज जो भी कांस्टेंट, जैसे लिमिट में हम करते थे कांस्टेंट टर्म को बाहर रख लेते थे, एग्जैक्टली द सेम। देन डिफरेंशियल इज डिस्ट्रीब्यूटिव ओनली विद एडिशन एंड सब्ट्रैक्शन। बीच में अगर प्लस माइनस साइन है तो ही आप डिफरेंशियल को अलग अलग कर सकते हैं। डी बाई डी एक्स ऑफ फर्स्ट फंक्शन प्लस माइनस डी बाई डी एक्स ऑफ सेकेंड। अनलाइक लिमिट, लिमिट में एक मैं फ्रेज यूज करता था दैट लिमिट इज अ हाईली डिस्ट्रीब्यूटिव फंक्शन, बीच में प्लस माइनस मल्टीप्लाई डिवाइड कुछ भी है लिमिट को डिस्ट्रीब्यूट कर देते थे। बट डिफरेंशियल इज डिस्ट्रीब्यूटिव ओनली विद एडिशन एंड सब्ट्रैक्शन। Then what is to be done if it is a product of two functions? If it is a product of two functions, then we make the use of product rule. Product rule is first as it is, differential of second. Second as it is, differential of first. If it is quotient of two functions, first function upon second function, then this is second as it is, differential of first. First as it is, differential of second, and whole upon second function of first. Last rule, we call it chain rule. जैसे chain reaction होता है, it's related, it keeps on going on. The same thing for chain rule. Chain rule is to be used whenever internally also we have a function. That is basically it will be used for the type function of a function. Chain rule को words में बहुत easily समझ सकते हैं. Multiply the differential by the differential of internal function. I'm not explaining you this point right now. This we will be doing after starting with basic differentiation. So this is due on me. This we'll do when we'll start the exercise based on chain. एक जल्दी से recap लेते हैं. There are three things in differentiation. Direct formula. The moment you learn these formula, you'll find differentiation to be very, very easy. Just these 10 results. Then we have that how we have obtained these results by making the use of first principle, one single formula which is so powerful that it can be used to differentiate any differentiable function. One example also we did. And these are the rules of differentiation, that constant function differential will be zero. If it is constant and a function, then constant as it is, and we need to differentiate the function. Differential can be distributed in addition and subtraction. For product, we use product rule. For quotient, we use quotient rule. And if it is function of a function, then we make the use of chain. Complete differentiation. Fx is equal to x to the power n. First one. Look carefully. What will be fx plus h? X plus h to the power n. What's the formula for f dash x? Before that, limit h tends to 0. Limit h tends to 0, fx plus h minus fx whole upon h. So here it will be limit h tends to 0, x plus h to the power n minus x to the power n whole upon h. To get it converted to a proper form, what will we do? What manipulation do we need? Take x plus take x minus. Now this will be n minus 1. So n x to the power n minus 1. This is the value of f dash x. So now we can write that's the reason that d by dx of x to the power n is nx n minus. I hope it's clear right now. Totally which chapter in school? Done. Now look for this. The second one, that is differential of a raised to the power x. What will be fx plus h here? A raised to the power x plus h. So this will become limit h tends to 0, a raised to the power x plus h minus a raised to the power x upon h. If the powers are added, the numbers are actually multiplied. A raised to the power x into a raised to the power h minus a raised to the power x upon h. Out of the two, what can we take common? And we can distribute the limit also. This will be a to the power h minus 1 upon h. There's no h involved here, so only a to the power x will be left. A to the power h minus 1 upon h will be equal to log. So we can write therefore d by dx of a raised to the power x is actually a raised to the power x log. Clear? Look. Easiest one, e raised to the power x. X plus h will be equal to e raised to the power x plus h. This will be limit h tending to 0, e raised to the power x plus h minus e raised to the power x whole over h. If the powers are added, the numbers are multiplied. E raised to the power x into e raised to the power h minus e raised to the power x upon h. We can take e raised to the power x as common, e raised to the power h minus 1 upon h. So this will be limit h tends to 0, e to the power x into limit h tends to 0, e to the power h minus 1 upon h. Now there is no h over here, so only e to the power x. This part will be, so we can now write d by dx of exponential function is same, e to the power x. Try doing it on your own without looking at the board. समझ आ सच बोल correct समझ आ रहा है सच बोल ऐसा तो नहीं बस ट्यूसडे को बोलता डेरिवेशन समझ आ रहा है डेरिवेशन समझ आ रहा है इसे कॉपी कर पा रहे हैं लेकिन तो ऐसे कॉपी करते करते राइटिंग अच्छी हो जाएगी तो कोशिश करूंगा खुद करने से आंसर अच्छा लगता है बातें सुनना now look for the most important one this one or similar one will definitely come in this so fx plus h would be sine x plus h so here it will be sine x plus h minus sin x अब मैं यहाँ थोड़ा डायरेक्ट करूंगा so please be attentive this complete portion is c and this is d sin c minus sin d what is sin c minus sin d 2 cos c plus d so can I directly write it as 2x plus h upon 2 sin c minus d x plus h minus x only h upon 2 upon h is it clear सिंपली सिर्फ साइन सी माइनस साइन डी का रिजल्ट यूज किया है, 2 cos c plus d upon 2 into sin c minus d upon 2 outside, limit h tends to 0, cos 2x plus h upon 2 into limit h tending to 0, sin h upon 2 and whole upon h. Right? What have I done? This 2 being a constant outside, cos के अपॉन में कोई टर्म रिक्वायर्ड नहीं है, तो इसको सेपरेट कर दिया. इट इज sin थीटा अपॉन थीटा which is 1, बट यहाँ भी बैलेंस नहीं हुआ है. व्हाट एल्स डू वी नीड? 1 upon 2. So इसको 1 upon 2 से मल्टीप्लाई. Now look, this 2 as it is, in place of h we can write 0, so this will be cos x, because cos 2x upon 2 will be cos x into 1 upon 2, and sin theta upon theta 1. This 2 and this 2 cancelled. This is equal to cos x. So we can write d by dx of sin x is equal to cos x. Am I clear with it? Do it now.